Anyways, the purpose of this video is to just go through this paper, as in some of the questions that were not answered correctly, so I am not going to waste anybody's time. Anyways, it says here, question number 1, right, in the diagram below, ABC has vertices A, B, and C here. This looks familiar. I think this is one of the questions in like the analytical geometry course. It says here AC is parallel to the x-axis, if I are not mistaken. Yeah, let me see here. AC is parallel to the x-axis, and then they said we should find the value of k. So obviously these have the exact same y value, you see, because the y value here is a 1, and this point here is nowhere up, it's nowhere down. So it means that the y value of k is also going to be a 1. And the longer I look at this question, yeah, it most definitely is part of the analytical geometry course, because if I just look here, let me see. Okay, so these are the files for the analytical geometry course, and this is the memo. So let me just open it up, because it's obviously like stuck in my head that, wait a minute, this question kind of looks a bit familiar, you know what I'm saying? It definitely does look a bit familiar. Let me just maybe open it with like a PDF file opener here. Let's see. Yeah, that question definitely does look familiar, man. Like, zombie. It's even, wait, is this one of the questions that's also there? I don't know. Let me just keep scrolling and see what comes up. There we go. Damn, it is exactly the same thing. Yeah, so this is obviously one of the questions that was in the analytical geometry course, hence why here we said k is equal to 1. But anyways, let's just carry on. K here is a 1, and then it says here calculate the length of AB. So calculating the length of AB, it looks like everything is fine there because of the distance formula. The next question here, it says determine the equation of a line that is parallel to AB and goes through the midpoint of AC. So this is a 4-mark question. We need to determine the equation of a line that is parallel to AC and goes through the midpoint of AC. So a line, so here, right, determine the equation of a line that goes through, what does it go through? That goes through the midpoint of AC and point B. So the midpoint of AC is this point here, and then obviously point B is up there. They want us to get the equation of this line. So getting the equation of this line, the first thing is a straight line obviously has an equation y is equal to mx plus c. So we just need the gradient and the y-intercept of that line. So the gradient of this line, we need these two coordinates to put into the gradient formula. So what we know is here this coordinate was given, the coordinate of E, we know that we can just get it by getting the midpoint of AC using the midpoint formula. Hence why this is the, you see, we're getting E, which is the midpoint. So here we got 11/2 and 1. Why am I yawning? Excuse me. So obviously from here we know that we just have to put the two coordinates into the gradient formula, and then we got a gradient of like -8. So us having a gradient of -8, we know that into the equation of a straight line, our gradient is -8, and we can throw in a coordinate that the graph passes through for us to get C, of which one coordinate that the graph passes through is B, which is 5 coordinate 5 there, which is giving us a y-intercept of 45, which is what we threw over there. So for C, I'm just going to take a screenshot of this, and I am basically just going to paste it on the, where am I gonna paste it? I'm going to paste it on the thing, on this question paper over here. So let me do that. Hopefully this thing will allow me to paste. Please allow me to paste. Oh, thank you so much. Let's see, let's just throw this over here. So let's make this a bit bigger. That's the way. I like it. Oops, shouldn't have done that. Anyways, moving on to the next. Hey, what is going? No, man, no. What you doing? Go back. Thank you. Anyways, the next question here says we should determine the size of angle ABC. So 36.8 7. The only issue is getting the angle of what you may call. Oh wait, it looks like it's a different question. Oh well, this one is asking us. I think they just changed this question. Determine the size of angle BAC. Where is BAC? Let's see where BAC is. B and then A here and then C over there. And then the one here is asking for well, it's the same thing. CAB is the same as BAC, because if you say CAB, it's exactly the same as BAC. So here obviously we can see that marks were given because of making use of like a previous answer, and we know that the actual angle for BAC would have been 53.13. The reason for that is obviously we know we can just use the tan formula, and we need to, let's see here, BAC, you can use the tan formula and you can use the equation, or rather you can use the gradient of line BA. You see, like what I did here, I extended the line BA, and then I know that whatever this angle is here, right, it's exactly the same as this angle over there, because these are like corresponding angles. So we know that the angle with the x-axis is all we have to find by using the tan formula, which is why this formula is here. We got this gradient by using the gradient formula, you see, because the two coordinates there, A and B, gave us this gradient. We threw that into the gradient formula for tan, and then we got this angle here, which is 53.13. Let's see if there's like a follow-up question here. Yes, there is, and it's a 2-mark question only. So actually, well, it's a different question. But anyways, let me just take a screenshot of this as mentioned, and then let's see what we're gonna get here. This is like D. Let's what do I need to do here? Break this down and then make this a bit bigger. Okay, let's save this, and then let us paste it over here. So let me paste this over there. Okay, I'll just put it to the side, just put it to the side. Yeah. Oh, whoa. I feel like I keep messing up. No, bro. Back, please. And then back again. Anyways, so the next one says we should write back. This one was okay. The next question, would you look at that? Also from the course, the analytical geometry course, which is, I think, literally the first question in the analytical geometry course, like the very first question that a person will bump into when they open the analytical geometry course is this question. So if you look here, they were asking for they said here, if PQ is equal to 9 units, determine the equation of Q. So if PQ is equal to 9 units and you need to determine the equation of circle Q, we know that firstly with circle Q, right, this is the standard form. This gives you the x value of the center, this gives you the y value of the center, and then we know that the radius, we know it's just a 4, because initially here, all this being red, right, they told us that let's see what they told us. They say that the radius of P is 5, but then here they're telling us that PQ is 9. So if this is 5 and PQ is 9, it means that this is just a 4. That's how we got the radius of 4 here. Now, us getting the coordinate of Q, all we said was, firstly, if this is P, right, if the radius is 5, it means that the distance here is 5 and the distance here is 5 as well, because you see the circle is touching the y-axis, the circle is touching the x-axis. So we know that going upwards, the y value here is a 5. So obviously, because this line here is nowhere up, it's nowhere down, if this y value is a 5, the y value of Q will also be a 5. That's why we got this 5. And then what we know is, touching the y-axis here, this is like x value of 0. So this is like 5 units to the right, and then 5 units again. You see, this would be like 10. And then from 10, 4 units to the right, this will give you like a 14. That's how we got this 14 here, because here you just were able to get the y and the x value here by observation. So let me actually just take a screenshot of what we have here so that I can paste it on this papyrus. So let me actually just paste let me not paste the whole thing, let me just paste let me just paste the whole thing. Actually, let me just crop this part here, crop this part here, and then let me just make this a bit bigger so that it like so that it like fits in, you know what I'm saying. Let me actually cover this whole thing. Actually, no, where are you going? Make this smaller. Let me actually just cover this whole thing, because whatever there is over there, it's the same as what there is here. You see, it's just like this is the question, this is the sketch. Now obviously the follow-up questions, these may be different, who knows, let's find out. They said here, find the length of QR if the equation of R is given by this. So getting the length of QR, let's see if it's the same question here. Yep, find the length of QR if the equation of the circle R is this and this. Now what we know is, if you think of the length of QR, right, Q is over here, R is up there. Now what we know is that you having to have been given the equation of what equation did they give you here? They gave you the equation of the circle with center R. You see, they gave you this equation. So us knowing that the radius here is a 2, we are able to get that by just putting this equation here into standard form. Now putting this equation into standard form, we just have to complete the square for the x, we have to complete the square for the y. So for the x, it's already done for us, fortunately. It's already in completed square format, hence why this just stayed the way it is. For y, completing the square here, we just have to have the minus. We know that here, when you complete the square, you have to add and subtract b over 2 squared, like on the left and on the right. So the b over 2 squared for y here is just giving us negative 11 squared. So hence we added this here, we added this over there, and then we know that these two should go in a bracket on its own, you see, which is how we ended up with this here. And then on the right hand side, we know that all this in your calculator will give you a 4. So that's how we know that this value is just r squared, because of this standard form over there, of which we know that if you carry on, that's how we got an r value of like 2 over there. So getting the length of QR, you see, as long as we had the radius here for 2 plus this radius here for 4, we know that the length here is just excuse me, it's just a 6. So let us just take a screenshot of this and let us see what's gonna happen. Let's see here, crop this out, crop this out, crop this out over there. Let me save this thing here, and then let me paste what we have over there. So let me just paste this over here, shrink it a little bit, paste. Okay, let me crop it a bit. It's fine like this. Anyways, let's move on to the next question. They want the length of AB. So obviously here, if the previous question is like not okay, then you'll always like get bubble marks, hence why this is like 4 out of 4. However, the length of AB, right, if you scroll up here, A is over here, and where is B though? Wait, is it AB? The length of AB. Hi man, where is B now? Let me zoom in. Oh, there is B. A here, A here, and then B there. We need to get the length of AB. So let us see how that was done, or let's see how I did it. So getting the length of AB, what we know is we can use Pythagoras theorem, right? In the sense that if you think of where P, R, and Q is, like if you look nicely, there's P here, there's Q here, there's R. That's a right angle triangle. Now we already knew that this was 9. We already knew that this was 6 from previous questions. So we can get the whole length of PR using Pythagoras, which is what we did here. We got PR, which is 3 square root of 3. Now 3 square root of 3, all we have to do is to subtract the 5 here, subtract the 2 over there, and then we have AB. That is how we got AB. So let me again just take a screenshot of this, crop this over here, and do this, do that, and let me just save this over here. Let me paste this here, and let me just make this a bit bigger, and let me also just make this a bit bigger. Anyway, so all that being done, let's see what is, wait, I think page number 6 nothing is showing, because I think the learner had like gotten everything correct on that one, so that's okay. Here this was like 5-mark question, everything looks 100% okay here. So if you want to see the answer, this is the answer. I can even like zoom in so that you can like pause and like check it out if you want to do that. Let's see here, this was out of let's see, what is the next question? The next question is out of 3, right? They said hence determine the general solution of theta. So firstly, if you look, right, this expression here is equal to tan 2 theta. So it just means that on the left here we can look at it as like tan 2 theta equal to 4. Getting the general solution here, we know that we can get our reference angle first, right? And then here this is actually going to be plus k180 over 2, you see, because here you divided by 2 to get theta on its own. So here you're going to have theta is equal to 37.98 plus k plus 1 plus 90k actually, and then k is the element of integers. See, that's why here it's just out of 2 and not 3 marks total, because of the part here where you divided by 2. Here you also have to divide by 2 over there. So anyways, moving on, this next question here, oh, so page 8 is also missing. I think page 8 everything was correct on page 8, or nothing was difficult, I guess. So here it says PR and S lies on the circle with center O, and then they said this angle here, let me just see if this was actually okay. There's only 1 mark missing, so this is like 106, meaning that this would need to be double, which is like 212, because angle at the center is double angle at the circumference. Now they said if you get the angle OPR, so OPR, which is like this tiny one here, we can easily firstly get this one over here using angles around a point, you see, because here 360 minus 212, right, is going to give us O1 over here, which is like this 148 over here. Now, this color is terrible, man. How can you write with the pink on white? That's how I always write on black, you see, because most colors pop on black. But anyways, here we're going to get 148, are we? Let's see, angles around the point, yes. And then it says here, we know that R1 and P1 are equal because they are radii. So what we know is technically R1 and P1, well, it's going to be 180 degrees minus 48 and then divide by 2. So this here, 180 degrees minus 48, that's going to give you 32. But then the 32 has to be cut in half. So that's going to give you a 16, you see. That's why here this is only for 3 marks and not like the whole 4. Okay, so we have Q, oh no, what do we have? It says in the diagram alongside, AQ is parallel to RT, which is fine. So they also said here we have the ratio of BQ over QC. So there's like BQ over QC is like 3 to 5. Okay, let's put 3 here. Yeah, 3 to 5. Okay, this one is kind of strange, but hey, gotta do what you gotta do, right? Anyways, and then the SS, they also said here BR. Let me put a variable here, variable K. They said here BR, where's BR? BR over RA is 1 over 2. Okay, fine. So let us, what color should we use? Purple. So BR over RA is just 1 over 2. So let's say 1, let's use a variable 1x and then 2x. So all this being said, what we know is that this 3 here can be split up using the ratio 1 to 2, you see. So yeah, let's not forget that, because this is like 3, right? And then the ratio here is like 1 to 2, so here this is also 1 to 2, meaning that here we can write this as like 1k, and this we can write it as like 2k, you see, because this is in the ratio 1 to 2, this is in the ratio 1 to 2 as well, because of these parallel lines over here. So the whole thing here is 3, so we've written these two with the k's there just to show that they go together. So here we can write 1k, here we can write 2k. Anyways, here the first question says calculate the numerical value of CP over RP. So where is CP over RP? CP over PR. Well, this one is actually kind of easy now, because if you look at it, whoa, out of 5, what? Well, I guess it's out of 5 because you kind of need to show that you know this, you see. So here we can just say BR over RA is equal to BT over TQ, which is equal to 1 over 2. Now, the reason here is third side of triangle. The third side of these two triangles here are parallel. Let me say this easier. This side is parallel, this line here is parallel to this line over there. So if you think of this big triangle here and this big triangle over there, their third lines are like parallel to each other. So here the reason for you saying that this over that is equal to this over that, you can literally just say third side of line inside triangle parallel to third side of your triangle over there. So the easiest way I can put it is, let's say line inside triangle parallel to third side, you see, because the line inside your big triangle over there, this line inside your big triangle is parallel to the third side of your triangle. That's why you've said that this is equal to this, which is also equal to 1 over 2, because our target here is to just say BT over TQ is 1 over 2. The reason for us saying that is because we want to have here 1 over 2 as the ratio for BT and TQ here. So that being done, we already know that this is just 1k, this is just 2k. So this being said, we can then say therefore let's see here, let's not start with the therefore, because like that's just weird. So we want to get CP and PR. So here we can say CP over PR, so it's like CP over PR. That is technically equal to like CQ over QT for the same reason, right? And the same reason is line inside, depending on how you write your reason here, I would just say line inside triangle parallel to third side, you see. So us having to have said that, we can then just conclude by saying therefore I need to zoom in here. Let's say therefore CP over R over PR is going to be equal to, let's maybe use a red, this is just the CP here, right, over the PR over there, it's technically going to be equal to 5 over 2, you see, 5 over 2 over there. And that red is not working, eh? The red is not working at all. Let's just put here 5 over 2 like that. Yeah, I think that's clear. So that's going to be for 5 marks over there. So after that, they want us to get for 3 marks the ratio of the area of RCB. Where is RCB? R, C, and B, right? That area there and the area of triangle ABC. Where is ABC? ABC. Wow. For only 3 marks though. Well, with the issue with questions like these is, if you look at RB and if you look at triangle RBC, And if you look at triangle ABC, what they have in common is the base. So what you can do for yourself with a question like this one, let me actually use a black. I mean, like I'm writing on white here. What you can do with a question like this one is write down an expression for the areas of the two triangles. For example, if you look at RB, let's say here RCB, right? Let's write it like this. For the top part, right, you have the area of RBC. The area of RBC, you know, it's half base times height. So your base is BC. So let's say here the area here is going to be a half. The base is just BC. So let's put here BC. And then your perpendicular height is like RT. So let's put here RT. So this is the area of the top triangle. The area of the bottom one is also half base times height. So you have a half. There we go. The base is just BC as well. And then the perpendicular height is AQ, you know. So you have AQ over there. So obviously if you simplify this, you are ending up with this half cancelling this half, this BC cancelling this BC. And then you can clearly see all you have to do is to get the ratio of RT over AQ. So RT and AQ, to get its ratio, you can already see, you can use this triangle here, the big one, and the small one over there. So if the ratio here is like 1 to 2, then you want to think outside the box with a question like this one, because what you can think to yourself is, this is like a full, you can think of these two triangles as two triangles. The small one here, let's see here, the small triangle over here is similar to like the big one over there, you see. So this is like A, Q, B, and then here this is like R, T, B, like that. So what we already know is that these are parallel, which is okay. What we're trying to say is we know that this angle goes with that one, this angle goes with that one up there, and then this one goes with there, because those are common angles. So what we know is these triangles are similar. So what we already know is that if we're looking at it nicely, right, this we technically can regard it as like 1, and then it just means that the whole of AB would be like 3 pieces, you see, because it's like 1 and 2, so it's like 3 pieces over there. And then what we know is this tiny part here, we can regard this as 1, and then here we can regard this as like 3 pieces. So what we know is if you're going to get a ratio for RT over AQ, let's see, but that's what we need, right? RT over AQ. What we can do is we just know that the ratio between our small triangle and our big one is just, for when we have 1, we have 3 there. You see, when we have 1 over here, we have 3 for the big one. So automatically it just means that if you look at it as a ratio, right, looking at these two triangles over here, what we know, just because of how ratios work, is that we can even just say BR, which is like from the small triangle, BR over AB, or over BA rather, we know that this is equal to RT over AQ for the big one, if we choose those. And what we know is that BR is just a 1, and then BA here is just a 3. So we know that we have our ratio here, RT over AQ, that's just 1 over 3. You see, so this is just going to be equal to 1 over 3. And we're getting that from what we said up here, you see. So that is that. Anyways, moving on to the next question, which is on like question number 5. We're working with statistics. What does it say here? It says the table below summarizes the mathematics assignment marks of a grade 12 group. So we are what? Yeah, we have a table here. It's like a table, and then we have marks, right? So people that got between 0 and 20, there were 3 of them. The midpoint of 0 and 20 is 10. And then cumulative frequency, you know, you'll be adding these up. You see, like 3 is just 3. When you add 7, you get 10. When you add 15, you get 25. When you add this, you get this much. When you add this, you get this much. So they say determine the estimated mean assignment mark obtained by the 12 people. So the mean is like the average, you see. So you getting your average for 2 marks. What you literally have to do is getting the average. You always have to say the midpoint times your frequency. You times all this together. You take your midpoint, you times the frequency and you get answers. You see, like here, you're gonna take 3 times 10, you get a 30. 7 times 30. Yo, what is 7 times 30 now? 7 times 30, that is, yo, I don't wanna guess, but it's like 210. And then 15 times 50. Yo, I think I should just use the calculator before I like end up making like a, you know, like a dumb mistake or something like that. So let's say here 15 times 50. That's gonna give you like 750, you see? And then 70 times 32, that's gonna give you 2240. So let's put here 2240. And then 90 times 8, you're gonna get 70. Okay, let's get this 70 here. No, 270 actually. Let me 720. So these totals here, you add them up together. So it's gonna be like 30 plus 210 plus 750 plus 2250. Yo, come on, 2250, 2240 actually, plus the 720. These here is like the total of all the marks, right? You're just going to divide it by how many people there are, of which this cumulative frequency is telling us that in total you have 65 people, because you added these 3 plus these plus these plus these plus these. So in our calculator, let's see what this is going to give us. We have there 30 plus 210 plus 720 plus 2240 plus 720. So if you divide that by 65, you're gonna get an average of like 60.70. So it's like 60.77, but to one decimal place is just gonna be 60.8%. Yeah, so here it says now determine, or it says draw a cumulative frequency graph, which is an ogive that represents the information in the table below. So the idea with drawing an ogive is our lines always have to be smooth, you know, and we know that drawing our ogive, we always have to use these ends here, like we always use the 20, 40, 60, 80 and the 100, and then we use it together with your cumulative frequency column, you see. So use this together with this, so meaning that for 20 it should be like 3, right, which is like fine. And then for 40 it's like should be like 10. So where's 40? 40, it's 10, perfect. And then 60, it should be 25. 60, we have 25, which is like in the middle, perfect. And then at 80 we have 57. 80, we have like 57 over there. And then 65, which is going to be the 100, right? So 65, 100. So it's like over here. There we go. So from the here, your ogive always has to start from 0. So you're gonna draw a line smooth like that, and then you're gonna carry on like that, and then your ogive ends over there. You see, because at 100 you can see that this is like at 65. Anyways, moving on, we know that it says use the ogive to determine the median mark. Show on your graph where you read this value. So the median, so in terms of the median, it's always going to be in the middle of your data. Like these are 65 people, so in the middle should be around 30 something. So here you only have 3, and then here you have about 10 in total by the time you get the 40% mark. By the time you get the 60% mark, obviously you would have gotten over the half of 65, because half of 65 is around 32.5. So 32.5 would fall in here somewhere, you see, because you're adding 3 people plus no, what am I saying? 32.30. Well, technically it would need to be like the 33rd person is the person that's in the middle. So the person in the 33rd spot would be here, because here you only have 3 people in total. By the time you get here, you have added up 10 people only. By the time you get here, you have added up only 25 people. So when you add a bit more people, you end up at 57. So meaning the person that's in like the spot 32 or 33 is in this range here of marks between 60 and 80. So when they ask you to use your ogive to determine the median mark, you can just use that graph, because remember the table here is together with the ogive. So whether you use the table, or if you use the ogive, right, you already know that 65 ends here, right? So in the middle is like 32.5, so it's like somewhere there. So using your ogive, you just need to trace that value here, trace it to your ogive, and then you just need to like bring it down. So you see here it's going to end between 60 and 80, which is exactly what we're getting here. You see it's falling specifically between 60 and 80 over there. So our median, let's see, they said here show on your graph where you read this value. So you just have to show this here. You just have to show that this is going to be like 32.5, and then as you can see here, this is, you can put an estimate of like 67% or something like that. You see that's going to give you 2 marks. Moving on, just remove these notifications here. Oopsie. Anyways, let's see what we got over here. D, it says we have pupils, a mathematics teacher wants to create a model by which she can predict pupils. So by which she can predict like the pupils, this word by which she can predict like the final marks of the students. She said here she decided to use her 2020 results. So prelim last year, these are the results people got. Finals, these are the results people got. Then they said here calculate the correlation coefficient. We know you can just use your calculator for that. Firstly, you have to submit all your data into your calculator, remember. So if this is the correlation coefficient, describing your data, firstly, it says here, well, when you describe the correlation coefficient, it's quite simple. You literally just have to state, firstly, this is very close to 1. So this is like very strong positive correlation. There we go. Very strong positive correlation. Here, getting a value for A and B, we know that's all just calculator work. Here it says we should estimate and predict a mark. This is what you would do. So all these, right, you can always just pause if you want to see how those were answered. Obviously, getting values into your calculator, you already know how to do that. If you don't, then I believe please go and view the videos on this channel. Like, good lord. Anyways, it says give a value for x for between 0 and 100, right, where it may not be a wise decision to predict a value of y using the line of best fit. Explain. This question is quite hard, eh? So anyways, between 0 and 100, right, this equation, you should always remember, it almost gives you an idea of somewhat a straight line graph. And this is almost like representing the y-intercept of the straight line graph, meaning that the lowest possible mark that they can predict is somewhat sure, this one is kind of hard. Like, I don't even want to lie, give a value. So you have to give a value for x between 0 and 100 where it may not be a wise decision to predict a value of y using the line of best fit. So whatever our line of best fit is, we already said this would be the y-intercept, meaning that if you throw x as 0, your y value would come out something like this. If you throw x as 100 in there, you'll obviously get a certain value. So the idea here is, it would not be wise to use your line of best fit formula for a scenario where x is a bit too high. Because if x is a bit too high, well, for example, if x is a 0, it's not an issue, because you would just throw a 0 there, your y value is like 9 point something. But then if x is like 100, let's throw 100 where x is over there. You're gonna have, let's see here, let's say someone got 100%, let's say 100 where x is, if you times it by 0.9, you're gonna get like 100.9, and then if you plus 99.96, you're gonna get like 110 or even 111%. So what I mean is, if x was like as 100, right, and you throw x in there, you see, it's not gonna work out. You see, it's not applicable. So choosing a value of x where using the equation is not advisable. You can even choose any random value. You see, x equal to 99. Let's say here, then you can say here, because you would get a y value bigger than 100. You see, of which the highest a person can get is like 100. So here you're just gonna choose a random value close to 100 that will result in you not getting a valid answer. So I say here x is equal to 99 because you can not get, let's throw x as 99 over there. Let's see what we get. 9.96 plus 0.90 here. Let's throw 99 over here. Let's see what we get. So because we're trying to say you cannot get that value, let's see here. So it's like 9.96. we have to say 99 times times the 0.1 over there. Let's see what that's, no, the 0.9, bro, come on, man. 99 times 0.9. okay, so if you add what does happen? 99 times 0.9, you need to add 9.96. so if you do that, this actually works out. Oh no, let's choose 100. Hey, because 99 works out, let's choose 100. Let's say x is equal to 100 because you cannot get let's throw 100 in here, 100 in there, because you cannot get 10.86%. well, if you round it off, it's just going to be 11%. so let's just say 111%, you see, because you cannot get 111%, because if you throw x as 0, you are going to get roughly 111%. so that's what you can put there for 5 for that question over there. Anyways, question number 6, it looks like it was not too bad. However, here we have a box and whisker diagram. It shows marks out of 80 obtained in a test by a class of like 9 people. So they're asking us to determine the skewness of the data. So in terms of you determining the skewness of the data, you always actually want to look to the side where you have like a longish tail. And one of the ways you can always get the skewness of the data, which it was basically like in one of like the tutorials on the main channel. What is that noise? Just search Bright Young Brains, bro. There we go. So if you look in like the statistics playlist, right? Let's just go to the statistics. Where's the statistics? Statistics. Where's the statistics playlist? We want here distribution of data, right? Now, if you even look at the thumbnail, wait, let's just skip this thing. Yeah, bro, just skip already, my guy. Skip. So if you go, let's just skip towards the front here where we have diagrams drawn. So in terms of you determining where something is skewed, like to the left or to the right, let me just pause somewhere where my head is not in the way. Maybe like somewhere there. So if you look at it nicely, see, being skewed to the left, the tail is towards the left side. Being skewed to the right, the tail is towards the right side. But as a calculation, this is what you can use, you see. The mean minus the median, if it's smaller than 0, it's skewed to the left. However, just looking at the sketch, you see, if this is a bit longer, then it's skewed to the left. So that's why here, this is definitely skewed to the left. You see, skewed to the left. You see, don't worry about saying positive and negative, you see. Just, you have to say where the longish tail is. So for 4 marks here, they said you should, in ascending order, the second mark is 28, yes. The third mark is 36, and the 6th mark is 69. They say the average mark is 54. Okay. The seventh mark is 4 less than the 8th mark. Okay, let's see here. Firstly, according to the box and whisker diagram, the minimum is around 20, the maximum is around 80. So these two are definitely supposed to be there. Now, looking at our box and whisker diagram, the median is 62. So that's why this is a 62, because that's the value in the middle. Perfect, because you have like 4 this side, 4 that side. Now they told us that the average is 54, so let's keep that in mind. However, they said the 7th mark, 1 2 3 4 5 6 7, the 7th mark let's just label it X. Oh no, let's not label it X. The 7th mark is 4 less than the 8th mark. So let's label the 8th mark X, meaning that this will be X minus 4, you see. So then they said here, what else? What did they say? The 7th mark is 4 less than the 8th mark. And then we don't know what this is though. Oh, this is gonna be like so difficult because like yeah, this is not fair. But let's see. In ascending order, the 2nd mark is 28, 3rd mark is 36, and then the 6th mark is 69. The average mark is 54. The 7th mark, yeah, 1, 2, 3, 4, 5, 6, 7th mark is 4 less than the 8th mark. Yes. Whatever this is just 4 less. So the only issue is getting this value actually. Because like how are we going to get this value if we don't have like, yeah, let's see if the previous questions can help us. They said if a learner had obtained 40% to pass the test, estimate the person. No, that's definitely not going to help us. The box and whisker diagram is also not helping us, but it might, because remember this is like Q3 and then no Q1, bro, come on. And then this is like Q3, right? This is like Q2. So the position of Q3, if you look at your data, right? Let's use our data to help us with this question, because looking at our data, what we know is this is Q2. Remember, in between Q2 and the minimum, you have Q1 over there. So the Q1 is 36. Here, you're going to have, in the middle of Q2 and the maximum there, you're going to have Q3. You see? So looking at your data here, you can already see, roughly speaking, did I put Q1? Yeah, Q1, but why is Q1 saying that it's like around 32? You see, that's why some of these things, to be honest, it's like so annoying, because it's like, but then why is it that we have Q1 here? Or rather, let's look at it this way. No, hold on. We know that this is Q1, 2, yes. What we know is, let's look at how many numbers these are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 4 to the left, 4 to the right. Perfect. This is in the middle. So obviously these are like 4 numbers, ne? 1, 2, 3, 4. In the middle is 31. You see, because that's where Q1 is. Now here what we know is 1, 2, 3, 4 numbers. So it means that in the middle we have Q3, right? Q3 here in the middle. It means that our Q3 here is just 75, you see. So the number in the middle here is a 75. So what we know is that this plus this divided by 2 should give us a 75. This, right, if you add your x and you divide by 2, it should give you 75. So let's see here. This is 2x minus 4 over 2 equals 75. So we're going to get like 150. No. Let's erase this out. Let's do this thing here. 150, right? Let's put like 150 over there. This is going to be 2x minus 4, right? This is going to give us like 150. And then 4 to the other side, it's going to be like 2x is equal to 146. Divide by 2 on both sides. You're going to get like 83. Oh well, so if x is 83, it means that we can throw in our values in there, right? So this is going to be, yeah, x is 83, therefore, but how are we going to get this one now? We'll use the average for that other one. Yeah, so let's just use, so x here is like 83, 4 less, this is like 79. So getting this value here, it's a matter of adding everything up and then making the average equal to like 54. Okay, this is what I mean. To get this value here, let's make this y. To get this y value, obviously all you can say is 20 plus 28 plus 36 plus y plus 62 plus 69 plus 79 plus 83. Oh no, this sucks so bad. This can't be 83 because obviously this cannot be 83 because that number is 80. Math Math is annoying. I have to rub everything out. But I guess this is okay because I mean, like, why is it okay though? I don't know. It's not fair. Like, it's really not. Huh? But are we getting 83 there though? Ha! I feel like I made a mistake. Yeah, I feel like I made a mistake. Let me actually see what mistake I may have made. 8146 divided by 2. That is 83, is it not? I'm not sure if you spotted the error, but I'm still looking for the error because I'm like, that doesn't make any sense. That number cannot be equal to... Let me see. Let's see. 75 times 2 is 150 minus... Oh no, plus 4. Yo, that's going to be even worse. Oh yeah. Yo, this is so bad. If you add 4, it's going to be 154. This is like 2x. How? This is going to be even bigger, Moose. Because it's not going to be 154 divided by 2, which is like 73. Oh, maybe. My calculations were just off. I'm sorry. Ekes Yamor, I don't know what mistakes. I don't even know how I got the 86 that time. But yo, hey. Oh well. We are learning. This divided by 2 is going to give us like 36 point... no, I already divided by 2, bro. Oh, this is just crazy. I feel like I'm panicking. The boy is panicking. Why are you panicking? Let me actually write my steps before I keep making the same mistakes over and over again. So here x would obviously come out as like 73, right? Or does it? Like, this doesn't make any sense though. How does x come out as 73? That's like impossible, bro. Just please calm down. And yeah, 77. Like, yeah, see, boy. Whew, I guess I was just like, no, I'm getting it wrong. No. But then it is what it is. Here we are. It's okay. Let's see. So that's just going to give us 77, which makes sense because it's at least lower than 80. So whatever answers you get, always try and double check them. This one is going to be 4 less. So this is like 73. So when you're adding up all these values, oh man, I rubbed everything out. I was about to say I rubbed it all out. Or say something dumb. But anyways, let's just see. To get the y value here, you would need to like add everything up, right? Plus the 36 there, plus the y, plus the 62, plus the 69, plus the 73, plus the 77. I never write my sevens like that. I don't even know what I'm doing it, why I'm doing it now. Plus the 80 here. This is just divided by how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Oh, 9, bro, not 8. You know that if you get the average here, it's just 54. So you have to get a value for y. So simplifying, what you're gonna get. Let me write a bit better here. Let's see. Take all this, shrink it, shrink it some more. Shrink it like that. Okay, fine. So if we were to carry on, well, we need to put all those numbers in the calculator. Actually, this question, it's kind of boring, but it is what it is. So plus 28 there, plus 36, plus 62, plus 69, plus 73, plus 77, plus 80. Okay, this is like 445, right? So it's like, let's see here, 445 plus y over 9 equal to like 54. If you multiply both sides by 9 to get rid of the 9 there, let's see, 54 times 9 equals to 486. So it's like 486 is equal to like 445 plus y. Why is that small? Nah, fam, what is this? Oh no, it's not that small. 486 minus 445, that's like 41. Whew. Okay, that kind of works out. So y is equal to like 41. Whew, thank goodness. Yeah, see, man. Damn it. This is like 41. Whew, thank you very much. So this next question is out of 2. They said the following information is given about the test results of a class. So what this is telling us is if you add up, all the data, it's 20 results to add up. If you add them up starting from the first one until the 20th one, this is telling us that you get a total of 1220. This is like adding up all the marks, all the results. So them asking us to get the mean, it's just going to be the 1220 divided by 20 people. That's going to give you the mean mark. So let's see what the mean mark is in the calculator over here. So according to the calculator, let's see here, 1220 divided by 20. Hey, what's going on here? 1220 divided by 20, that's just 61. There we go. Then it says get the standard deviation. The standard deviation. Well, the standard deviation, remember, I think this is like in the statistics course. The standard deviation gives you an average of how far each piece of data is away from the mean, meaning that literally each piece of data, you take it, you subtract the mean, and then you square it. You take it, you subtract the mean, you square it, going on and on and on and on and on, and then you basically divide that value by the pieces of data that you have. So this is going to be divided by 20 pieces of data, and it is going to give you, let's see, 196 divided by 20. This is like 9.8. So obviously if you double check in like the stats course, let's see here, I think if the course is let's just go to statistics, and let us go to like the statistics memo. We are going to be faced with the following. Obviously this is like I just want to go to like a portion where I wrote out what standard deviation is, because it's like super duper important, you see, or for us to know what the standard deviation is. I think I remember writing it in words, what the standard deviation is, because I mentioned the standard deviation tells us on, like here, standard deviation, just the definition. You see, standard deviation tells you on average how far each piece of data lies from the mean. So if you think of it nicely, you see, it tells you how far each piece of data lies from the mean, you see. Hence why here, if you look at this calculation is checking each number, how far is it from the average, you see, because you remember, if you're going to check how far two numbers are from each other, you're going to take one of them and you subtract the other. So because we're talking about how far each piece of data is from the mean, you're squaring here because you're dealing with like just the distance between the two numbers, you see. That's how you're squaring everything, you see. The distance between these two numbers, if you square it, you're always going to end up with like a positive number. So you add all those up. This is showing you that you add everything up, all the distances for the 20 numbers. So the average of that is just going to be this 126 here, this 196 here over 2. So that is what you are going to, no, over 20, that's going to be like what you may call 9.8. That's okay. So that's just for 2 marks. Let's see here, the next question. Let's see, what did they want here? It's out of 6. They said we should determine the values of x without the use of a calculator. Okay, if this whole thing here is equal to 40. So yeah, this is dope, realizing that we have this is just like a compound angle expression, and with this compound angle expression, see, this is not, you cannot distribute a trig expression into a bracket, you see, because this here is the angle of the trig expression. This is not a variable. You cannot say sine times x and then sine times the 20 that you see. So what you can do here though is, we already can see that here they just want us to, what do they say, without the use of a calculator, we should get, let's say here, determine the values of x where this left side is equal to the right hand side. So what we can do, excuse me, is we can use the reduction formula, like where we see the cos here, we can change that into sine 90 plus the 40. You see, because sine 90 plus gives you the cos here. So obviously from here, because you have a sine here, you have a sine here, the only way these two sides can be equal is if you work with what's on the inside of your brackets here. You see, so here you can say therefore x minus 20 is equal to 90 plus 40. And then what you're gonna do now, so what you want to do is anytime you do this, always have one where you work with the right side as a positive, and always have one where you work with the right side as a negative. So let me just put here this so that I end up with like with my two different answers. So this is like the first answer, this is going to give you the second answer. So here, if you take this over to the other side, you're going to have x here, 90 plus 40, that's like 130. This goes over, you're going to plus a 20, that's like 150. That's your value of x. Now here, this is like, let's see what you're going to get here. If you multiply inside the bracket, you're going to get negative 90. Wait, let me just 90 plus the 40 is going to be 130. So here you're going to end up with like negative 130. And the 20 is going to go over. You're going to have x here is equal to what? Negative 110. And then here you have an x is equal to like 150. But you see here, they said between negative 90 and 180. So it means that this one is like not applicable, because you see this is like below the negative 90 there. So 150 is between negative 90 and 180. And these will be your two answers. This you have to put there, otherwise you're gonna get penalized. Anyways, let's see. They have given us a pattern. Okay, consider the following pattern. Well, this is kind of annoying. Like, what? A pattern? Like, what the hell, man? So anyways, let's look at the pattern. What does the pattern say here? It says we have this with the 2 there. So it's cos squared 2 minus sine squared 2. Let's see what you're gonna do. Cos squared 2 minus sine squared 2. Let's see what happens if you square it. Yeah. Okay, let's look at the pattern. What kind of a pattern is forming here? Oh, so there's a sine squared 4 here, and then they bracketed that, and then they squared it, then they put sine 8, then they bracketed that, going on and on and on. So meaning the next one would have probably been like a 16, because it looks like they're just multiplying by 2 all the time. Okay, yeah, you see here, this is showing that they're just multiplying by 2 every time. So it says here, simplify t1 and t2 to a single trigonometric ratio. Okay, so we have to simplify both of them to a single trig ratio. Well, this here, right, should remind you of your double angle of cos, because your double angle of cos says that cos squared alpha minus sine squared alpha, this is equal to cos 2 alpha, like that. So meaning where we see alpha, in our case here, there's just a 2. So it just means that where we see this over here, we know that this is just cos with a 2. The angle here is a 2, right? So it means that this is just going to be a 2 over there. Meaning if you simplify it, you're going to have 2 with this whole thing here squared minus 1. So let's see what this is going to come out as. This whole thing here is going to come out as the 2, right? Inside the bracket here, it's squared and then minus 1. So that's where the cos 2 times the 2 is going to go in. So it's actually going to be like cos 4 squared minus 1, you see. For the second ratio, if you look at it nicely, right, let's see, we already know what this is going to come out as. This is going to come out as cos this is not squared. This is definitely not going to come out as squared, but then when you do square it, that's where the square is coming from there. So here though, what we know is, you see this thing here, it's going to come out as cos 2 with a 2, and then you're going to square it, right? Meaning that here you're going to have 2, which is the 2 out there. Here this squared here and this bracket here, inside the bracket, right, you're obviously gonna have like cos with a 4 because of this here, and then you're just gonna square it over there, and then minus let me color code the brackets, because you have a big bracket over here, and then which is this one, and then you have this thing here squared, which is going to be the cos 4 squared, right? And then you're minusing sine 4 squared, sine to the power 4, no, it's not to the power 4, it's the power of 2 with the 4 there. And then that actually should be the pink bracket as well, like the purple bracket. Let's put the purple bracket over there. And then from there we know that outside we're just going to like subtract the 1. So in here now we know we can use this example as well. You see this example here, we know that whatever this is, it is, remember this squared and having a square there, it's the same. You see this squared can be there, it doesn't matter. These two definitely are the same as this. So the 4 here would go over there, meaning that inside your purple brackets there you would end up with like cos 2 with a 4 there, which is like cos 8. So the purple brackets here, it's just going to be cos 8, and that is obviously like squared over there because of this square over there. So here you're just gonna give you, it's just gonna give you the 2 out there, you're gonna have cos 8, and we said that is just squared, and then you're just gonna have a minus 1 over there. Whew, there we go. This is kinda like a crazy weird question, but those are your 2 trig ratios. You're gonna get 4 marks for that. It says for 2 marks, write down a simplified formula in terms of n for the value of Tn. Oh well, what we can already see here is for T1 this is a 4. For T2 the only difference is that this is an 8. So we can think of the 4 and the 8 only. You see, you can almost think of a sequence where you have like a sequence where you have like 4 here and 8. The next one is, you can think to yourself, is it going to be a 16? Yeah, it looks like the next one would have been like a 16 because of this here. You see, the trend is that here when you multiply it by 2 you got a 4, and then here when you multiply it by 2 you got an 8. So here if you're going to multiply by 2 you're gonna get a 16. So here you can think of a scenario where, if you think of a sequence where it's like 4, 8 and 16, just thinking of this sequence, the general term here is that Tn is equal to, let's see, this is just you're just multiplying by 2 every time here. So you can think of Arn minus 1. The first term is a 4, your R is just a 2, you see, and then n minus 1. This is for the number 4, 8, 16. So what we can already see is the only thing that's changing here is the number here. You see, it's 4, and then it's going to be 8. The next one would have been like a 16. So it just means that the general term for this one that has the trig ratio, you can think of it as Tn is equal to, let's see the stuff that stays the same. Here you have a 2. Let's just put a 2 there, and then you have an open bracket with cos, open bracket with cos. Inside the cos there's a number that changes, and then outside that we know that the whole thing is just squared, and then we know that you have minus 1 over there, minus 1. This is what changes, right? This is the only thing that's changing. And then this thing here, we know it's determined by this formula, so you can put a 4 here, 2 there, and minus 1, because this is the only thing that's changing. The 2, the cos, the squared, and the minus 1 is staying the same, because here it's just starting with a 4, then it gets an 8 in there, the next one would have a 16, going on and on and on and on and on. Anyways, that is that for that question. The graph of f of x is equal to 2 sine x. Then they said it is between negative 180 and positive 180. Then they said here it is sketched below, right? So they said here we should sketch the graph of g of x is equal to What else? Sketch the graph of, let's start from the beginning. The graph of f of x is equal to this, ne? And then it says for x is between negative 180 to positive 180. Fine. And then they said here, sketch the graph of g of x is equal to this between negative 180 and positive 180 on the same set of axes. Oh, okay. So this is basically a standard cos graph that has been moved 45 degrees to the right. So let me just draw what a basic cos graph would look like. It would pass over here, and then at positive 180, right, that's when it would like turn here. At 90 it would cut the graph. Like if a normal cos graph would look like this a bit, you know. No, hold on, it shouldn't go down there. It would look something like this, come down like that, and then when it's going towards when it's going to like 360 to do that again, you see. So this is just a normal sine graph. This is what it would look like. This is what cos x would look like. You see here it would go at negative 90, it would go down there. This is if you had cos x and you were just looking at it. But then the moment you move it 45 degrees to the right, then obviously this blue image here, right, everything gets moved 45 to the right. So instead of cutting there at 90, it's gonna cut here at like negative 45. So let's move that somewhere there. This is what your image is going to look like. You see, instead of cutting there at positive 1 there, it's just going to be 45 to the right. And then obviously here, this would be your new turning point now. Your graph would then just be, let's just do that. Let's just remove that part over there. And then let me just remove that part over there. Perfect. Anyways, this is all good here. Let's see how many marks they were offering. Just 3 marks, you see, because it's not a difficult question. So here, showing all relevant points, you see, turning point over there, things like what else? This is going to be, yeah, this is definitely relevant. This is definitely relevant. For 2 marks, it says use the graphs to determine the following. It says here, if f of x is bigger than 0, meaning you're talking about if x is bigger than 0, you're talking about the positive side here. It says if x is bigger than 0, for which values of x will this expression be a negative? Okay, so what they mean is looking at the right side of your image, right? They want you to determine, oh, this is correct. Nice. It's 3 marks this. So I guess this is already correct. So we don't have to go through it for now. Because all you have to do here is you have to think to yourself, where is this a positive while this is a positive? Because that's the only case where you're going to get like what you may call a positive number here. No. This is asking where is it smaller than 0. So meaning you have to look for a point where this is a positive number while this one is a negative, or you have to look for cases where this is a negative number while this one is a positive, vice versa. You have to look for cases where this is a plus while this is a minus, or a case where this is a minus while this is a plus. So we can already see that that's only happening specifically. Would this be a thingy now? Let's see. This is like at 90, right? So obviously if you move it 45 to the right, it's definitely going to be at positive 135. So let me actually show it here. It would be cutting that point over there, because remember initially it was like cutting at 90. So now it would definitely be like cutting at 135. So that's a relevant point. Yeah, I would say the graph was okay. You see here, the reason why this is in red is because it's supposed to cut there. The reason why this is in red is because it's supposed to cut there. So you have like negative 45 here and 135. So the only x values where these have like positive, they have like opposite y values, it is only from the 135 going to 180. You see, from 135 going to 180. The 180 is not included because at 180 one of them is equal to a 0, you see. So this here is irrelevant because it's towards the left where you have like negative values. They just asked for where x is bigger than 0. So that first line here should have not been written. Then it says you determine the values of k such that f of x plus k will have no real roots. So the graph of f of x is just this black sine graph here. So for this graph to not have any real roots, it means you either have to move it up until you don't have any x-intercepts anymore, and you need to move it up at least 2 units upwards, right? So if you think of it, you either have to move it at least 2 units upwards, it's not going to have any x-intercepts, or you need to move it at least 2 units downwards, it's also not going to have any x-intercepts. So as an answer here, you can literally say k has to be bigger than 2 or k has to be smaller than 2, because if you think of it, right, if you're plusing a number that is bigger than 2, it means that you're moving the graph more than 2 units upwards. If you're minusing a number that is like, if you're minusing a number that is smaller than 2, it means that you're moving the graph more than 2 units downwards, meaning that your graph would also not be having any x-intercepts. Because you see, if you move this graph downwards more than 2 units, it won't touch the x-axis at all. And let me actually visualize it just in case we have some questions. So obviously here, this is what your sine graph looks like. We know that with that particular sine graph, if you move it 2 units downwards or more than 2 units downwards, you see it's not going to have any x-intercepts. If you move it more than 2 units upwards, you see it's not going to have any x-intercepts. So that's what we have to remember over there. Let me put this back. Anyways, let's see what you're gonna do when they come for you. Let's see here. This is okay. Now with this question here, there's so many words. Whoo-wee. It says here, what did it say? So many words. Yes, like it says the high and low points of the section of a roller coaster track are separated by 60 meters. So it's like from here until there, separated by 60 meters horizontally and 30 meters vertically. And then it says here the low point is 3 meters. Oh, hold on, man. Oh, the low point is 3 meters below the ground. Okay, so this part here is 3 meters below the ground. Okay, and then this is like 30 meters up. So from here to there, it's like 33 meters. Okay, and then it says here the section of the track is in the shape of a cosine function. Nice, it's in the shape of a cosine function. Let y be the distance in meters, and then it says the track is above the ground, right? Let y, y is representing the y-axis, x is literally just representing the x-axis. We shouldn't even be thinking of a roller coaster track here. We should literally just be thinking of a sine graph. And then it says here let x be the distance in meters, and then it says here distance in meters, a point on the track is from the right, going on and on and on. So they're just trying to explain that look at the graph from top to bottom as though you have like a Cartesian plane here, and from left to right also just think of a Cartesian plane. And then they say that the equation of the function is given by this gives us the amplitude, this gives us the frequency, and then this gives us a shift from top to bottom. Anyways, what we know is that they told us that this is the lowest point, you see. So between the highest point, which is like 0 up there, and the lowest point, which is like at 60 meters here, let's see. Yeah, this is basically giving us an idea of like a period of 120. because what we know is like this is just like half a cos graph, right? So another half, that would be at like 120 meters. But anyways, they say we should get all these values. So firstly, what I already mentioned was the period. The period here is going to be 120. The reason is half the graph is at 60. So another half would give you the full graph, meaning it's taking like, let me just write it like this, 60 times 2, this is 120. That's the period. The reason you want the period is because the period will give you the frequency, because the frequency is always 360 divided by, the period is always 360 divided by the frequency. You see, so in this case, 120, why am I writing it like this? Let me just write it in such a way that I get frequency. So the frequency is going to be equal to 360 divided by the period. You see, which is just going to be 360 divided by 120, which is just a 3. You see, of which the period, the frequency is just given by B here. That's the frequency, you see, from the theory that you know. That's B. Amplitude, clearly it's the difference between the highest point and the lowest point divided by 2. So the highest point, let's just write as a formula. A here, highest point is 30, lowest point is like technically -3 divided by 2. So this is like 33 divided by 2. 33 divided by 2 is going to give you 16.5. You see, 16.5, that's the amplitude, so that's your value for A over there. It's just going to be 16.5. This looks like 18.5, so let me just change that. 16.5, so that's A, amplitude, B for frequency. And then a shift from top to bottom, yeah, this graph is not touching a cos graph would normally, what would it normally do? A cos graph would normally have the x-axis running along its middle part here, like somewhere in between the 30 meter mark and the -3 meter mark, like in between here, right? What I'm trying to say is the graph definitely has been shifted up or down, because a cos graph would normally look like this. You see, it goes from like a point up here and then it goes to like a point down there. So the x-axis should be like in between the highest point and the lowest point. This is if your graph is in standard form. So what you can think to yourself is, in terms of you determining how far up or how far down your graph was moved, just compare your lowest point and just think to yourself, where is the middle of this graph? You see, between 30 and -3, you see, between 30 and -3, the middle of this graph, we said it would be somewhere from this point, right? The middle would be 16.5 units upwards. So from -3, 16.5 units upwards would be at 16.5. From this is the lowest point down here, right? So if you go 16.5 units up, you're gonna end up at this coordinate, which is like 13.5. So what I'm trying to say is, technically speaking, right, if your x-axis runs along this part here, it means that your graph would need to be moved downwards a total of like 13.5 units, you see, because obviously if you move this cos graph here 13.5 units downwards, let's actually do it. If you move it 13.5 units downwards, right, or rather, yeah, if you move it 13.5 units downwards, you're going to have a scenario. Let me take it together with like the dotted line. You see, if you move it 13.5 units downwards, it's gonna be something like this, you see, where this is what it would look like originally. So originally it looks like this. This is what it would look like if there was no vertical shift at all. But then what we know is that this graph was moved upwards a total of 13.5 units, and then now you have it looking the way that it looks now. We said this is 13.5 units. The reason is this tiny space is like 3 units, you see. So from the lowest to the highest, somewhere in the middle is where your x-axis would be if your graph was not shifted at all, you see. However, our graph was shifted, you see. Our graph does not look like this. If it looks like this, there would be no vertical shift at all. But then instead our graph looks like that, meaning there is a vertical shift, and that vertical shift was a movement of 13.5 units upwards. So that is why here our value of let me put this back, our value of q, it needs to be equal to 13.5 as a positive over there, 13.5 units. That is that. Let's see here. Determine the horizontal distance from the high point to where the roller coaster goes below the ground. Determine the horizontal distance from the high point to where the roller coaster goes below the ground. Really? Are you joking? Hi. Oh, the horizontal distance from the high point to where the roller coaster goes below the ground. What? Highborness. These questions are starting to act funny now. Because let's see. Determine the horizontal distance from the high point to where the roller coaster goes below the ground. Oh, okay. I get it now. What they mean is, firstly, this is the high point, né? And this is its x value. This is the point where the graph goes below the ground. So if they say determine the horizontal distance from the high point to where the roller coaster goes below the ground, it means they want this distance here from here up until the point where the graph goes below the ground. You see, that's the distance that they want, because obviously this is the high point. Its horizontal x value is like here at 0. This is the point where the graph goes. This is the point where the roller coaster goes below the ground. So they just want this distance here, meaning you just should use your equation and work out where y is a 0, because you see this is an x-intercept. So your equation, we know that our equation, it is this, right? It's y is equal to something. So here we know that y, write this in blue. Let's see here, y is equal to 16.5 cos our frequency, we said it was a 3, so this is like 3x, and then q is like positive 13.5. What else? 13.5, right? Yeah. So let's see here. We just need to work out where y is a 0, right? So you'd put here 0 is equal to 16.5 cos 3x plus 1, that. Take the 13 point something over. You're gonna have like 13.5 is equal to negative 13.5, and then 16.5 cos 3x. Divide both sides by 16.5. You're gonna have negative 13.5 divided by 16.5. This is gonna give you cos 3x, right? And then let's see what else. Shift cos. So here you're gonna have, you have to get a reference angle here. Well, not necessarily a reference angle, you can just do shift cos here. So it's gonna be shift cos with like negative 13.5, 16.5 there. Come on, bro. This is gonna be equal to like 3x. And then let's see what you got. Shift cos. You now have to use the calculator now, and I don't got a calculator. Would you believe it? Oh no. I'm like so far from the calculator. Like if I told you what I am right now, you would believe me, but I can't believe I didn't bring a calculator, bro. Like, why you gotta do that? Ish. Anyways, let me just try and see if I can finesse this question here. Let me actually pause. Anyways, I guess the tablet came in clutch. Anyways, 35 point, we can just round it up to 35.1, the shift cost part. So, this is kind of like a scary answer, hey? Because the whole thing is like 60 days, so like, how can that be? Ay. This is just like, oh my goodness, Wait, no, I made a mistake. This one is not supposed to be a minus. It's supposed to be a plus, so yeah, much better. We can round this off to like 144.9. So this is like 144.9 equals to like 3x. Hey, even though. So if you divide by 3 here, it's gonna be close to 50. Oh, nice. Thank you so much. Thank you so much, calculator, for doing the things for us. So let's see here, 144.9 divided by 3, that's like 48.3. That's definitely believable. 48.3, which is okay. 48.3, this is like 48. There we go. Go. So what else? Yeah, so we now know that this x value here is around 48.3, you see. So the distance, let's say here, distance equals 48.3 units. There we go, because we have basically gotten the x-intercept of the graph over there. Anyways, this question is Euclidean geometry, so hopefully we are about to at least have some fun, like, cause it's been rough, the last few questions. But anyway, it says here 2 circles touch internally at S. So you have like a big circle and you have like a small one, right? So 2 circles touch internally at S, and then it says here O is the center of the bigger circle. Okay, so the diameter of the big circle so the radius of the big circle looks like it's the diameter of the small one. Oh, they even said it here. But anyways, O is the center of the big circle, passing through P, V, and R and S. It says here OS is the diameter. Wait, OS and VR are the diameters of the smaller and bigger circle respectively. So if this is the diameter, this is 90 automatically. We can put that there. And then what else? They said here PR, let's see, PR and SV are chords. Yes, they are. Of the bigger circle intersecting the smaller circuit W. Excuse me. This question should be okay. Prove that SW is equal to WV. Why didn't they just call it VW? Let's see. Prove that SW is equal to like WV. They need you to prove that this is equal to that, of which this is just a theorem that we're looking at here. This is equal to this because this is a 90-degree angle. Remember, if you look at the big circle, right, a line from the center of a circle, if it bisects a chord at an angle of 90 degrees, then it bisects it in half. So here we can just say here, we need to show that this is 90, right? So we can say here OW is perpendicular to that. The reason is it's not a line, line from center of chord. Not necessarily. The reason why is angle in semicircle. You see, you're not sure that this is 90 because it's an angle inside a semicircle. There. Because you don't know that these are equal, you cannot assume that this is 90. You see, that's why this reason they didn't take it. So here you have to say line, you have to say angle in semicircle. And then and then here you can then say therefore SW is equal to SV because line from center of chord. Okay, line from center. Here at least they should have given like at least 1 mark, line from center of chord. Line from center of chord. Then just end it there. you see, or line of center of chord is perpendicular to, yeah, no, just line of center of chord is enough, you know. Don't overcomplicate it, because obviously you're going to get like 2 marks for the statement here and the reason, because this statement is correct, you see. OW is perpendicular to SV, and there's the reason, you see. At least because there's no reason, you should have gotten 1 mark for like just a statement, but it is what it is. The next question, they want us to prove this expression over here. Now you can pause to look at the reasons mentioned here so that you can answer this question, or so that you can see why this was correct, like full-blown 6 marks. Wait, why is it only 5? 1 2 3 4 5. How? Okay, well, they did give the whole 6, so it's okay. Let's move on here. Let me just put a random tick just for the vibes. The next question here is, they said we have in the diagram below A, B, C, and D are points on the circle. A, B, C, and D are points on the circle. So this is a cyclic quad, as we can see there. They said BED is theta. EB is equal to like ED. And then it says here they are tangents, so meaning they're equal to each other. Tangents from the same point are equal, you know. So if you're going to use that reason, so here the reason is tangents from the same point. You see, tangents from the same point. Tangents from the same point. There we go. And then here, determine an equation. No, determine an expression for BCD. So BCD, you need an expression for that in terms of theta. Well, I don't see the mark allocation here, but anyways, the idea is, we know that this is a cyclic quad. I mean, yeah. So, yeah, the only thing is the mark allocation is missing now. So I'm just like, oh no, oh no. No. Anyways, what do we know? Yo, do I need to make like a construction or something? Ah, yes. No. Oh yeah, let me do it. I think making a construction is easier. So here, if you construct, let's label this O. OD and OB. So you can even write it as, because you have constructing this now and you're gonna use it, just tell them, you see, construct OD and OB. After you've constructed that, what you already now know, man, I feel like I'm flopping here. Oh, I'm not. What you already now know is that this is 90 and this is 90. So what? Okay, let's just tell them. Let's say here OD is perpendicular to DE. The reason is the tangent here is perpendicular to the radius. That's the reason. Here OB is perpendicular to BE. The reason is, again, a tangent is perpendicular to a radius. The reason why you want to say this is 90 and this is 90 is because at least you have theta over here, right? So you can get an expression for this angle over here. This angle over here is obviously going to be 180. I mean, no, all the angles of this four-sided shape is 360, right? So this angle here is, let's say, DOB here. Let's label it O1 actually, and label this side O2. Here we can say that O1 is equal to the following. O1 is obviously equal to like 360 minus 90 minus 90 minus theta, which is going to be 180 minus theta. The reason is interior angles of a quad. Angles of a quad. We're not saying a cyclic quad, it's just a quadrilateral. Any four-sided shape, remember, all interior angles add up to like 360. So here, that's what O1 is, you see. Now, we know that to get an expression for BCD, we can use O2, because O2 is double BCD, you see. So let's get O2 first. O2, it's going to be equal to 360 minus this thing here, because of angles around the point. Angles around, what you doing, man? Angles around a point. There we go. So these angles around a point, let's see what they can do for us. So we have O2 now, right? O2 is definitely then going to be like what, 180 plus theta. Yeah, 180 plus theta. It's just a coincidence. It's just crazy how it is, but you do use what it is. So here we can then say, therefore BCD is equal to, we know that BCD, we don't have to say therefore, actually it's not a conclusion, it's just saying a BCD is equal to half of whatever O2 is. The reason is angle at center of circle. There we go. Then we can say here, therefore, let's write this in like a lighter color, therefore BCD is equal to half of 180 plus theta. There we go. That's going to be an answer. I think this question was not out of 1 mark or 2 marks. I think it was like at least a good 4 or 5 or something. Woo! Yeah, ne? He's deep. He's deep. Anyways, this question, what does it say? It's out of how many marks? 7. It says the equation of a circle is given by this. Okay, and then it says prove that the radius of the circle can never exceed square root of 13 for any value of theta. Show your calculations. So looking at what we're given here, the one thing that comes to mind is to just put the equation into standard form first, and then show that the radius can never go above this. Like, just put it in standard form first. I would safely say try not to worry too much about the cos and the sine. You see, that's just some gimmick to try and throw you off your game, so don't pay attention to it. Let me actually just start down here. So here you're gonna put there, let's write the ones with x together. So this, let's write it with the 4x cos theta here plus 4x cos theta. The ones with y squared plus 8y sine theta. Let's see, and then what else? This with that plus 3 equal to 0. Let me just stroke this thing here. Let me zoom in a little bit. Do that. Okay, now what? Okay, let's just think normally. If we were just doing this question without worrying about the cos and the sine, we would just complete the square. Now completing the square, remember we have to get b over 2 squared for both x and y, and then we add it on both sides of your equation. This has to go to the other side, so let's just take it to the other side already. Minus 3. Anyways, so let's get the b over 2 squared thing. So for the x, right, your b over 2 squared is going to be your b is technically 4 cos theta, because the x is is the variable. So let me write this in a way that shows that 4 cos theta is your coefficient, and then let's put this what do we need to do here? Swap the sine and the y there, so this is like 8 sine theta with the y over there. So the b value here is like 4 cos theta, right? So it's like gonna be 4 cos theta over 2, the whole thing squared. This is just gonna give you 2 cos theta, right? Don't square it, just leave it like that. Now for the y, your b over 2 squared thingy is going to be 8 sine theta, so it's like 8 sine theta over 2 squared. this is like 4 sine theta, the whole thing squared. So this is what you have to add on both sides. This is what you have to add on both sides. So let's just do that, you see. So doing that, we're gonna have here let me actually make this a bit smaller so that I don't like lose space unnecessarily, but it is important, that thing that we just did here, very important. So anyways, let's make sure we don't get thingied. Come on, this thing is like distracting, so let's actually just get rid of it. So let's finesse it quickly, do that, make this much bigger, and then just mask it out. Ha ha ha, that's the way. All the way good. Anyways, so let's see here. X squared plus 4 cos theta x plus y squared. Oh no, I'm supposed to add the x's thing here. So obviously here, this is where we need to like add this value, right? So plus 2 cos theta, the whole thing squared. And then for the y, we just carry on, plus y squared plus 8 sine theta y. And then here we know that we need to add 4 sine theta squared. 4 sine theta squared. And then it's going to be equal to like -3 with the others, you see. It's going to be -3, right? With this and that, you see, added as well. So it's going to be plus the 2 cos theta squared, and then also plus, let me remove the funny looking brackets because that's just I guess we can just see I've just run out of space here. So oopsie, ish, man. But bro, just write smaller. Like, what the hell, man? Just write smaller. Okay, let me finesse this thing. I do have the ability to do that. I mean, like, come on, bro, just make it much smaller, like 8. Use a color that's like visible, bro. Let's use the black. Done. No, you darn thing. What just happened? Yo, this thing. What kind of nonsense are you trying to pull now? Let's see, let's do this thing here. Oh, this is here. Oh no. Come on. This is just annoying. Let's make this a bit smaller then. Let's do that. Yeah, this should be fine. So here on the other side, right, we obviously know that we have to like add those two things. So let's do it. Let us do it. So let's like add, let me actually write a bit smaller now since I've learned my lesson. This is gonna be adding this as well. 2 in brackets, we need to add 2 cos theta squared. Then here we have to add 4. Okay. So completing the square, as we have already said, as long as you do this, you're just going to take this with its x part, then you throw them in brackets. 2 cos theta squared. For the y, you take the y and this value here, you put it in brackets squared, you see. And then on the other side, you're basically just going to have this whole thing. You don't have to, this you can just simplify. It's going to be -3. 2 squared is going to give you a 4. Then your 4 squared there. I mean cos squared here. And then 4 squared is going to give you a 16. And then you have like sine squared over there. Okay, so we're trying to deal with how here they said show that the radius will never exceed square root of 13. So this side here is what gives you the radius. Like the square root of this number is what gives you the radius. So the right hand side does not matter much anymore. The left side is what we need to deal with this for this question. So let's see here. -3 plus 4 cos squared theta plus 16 sine squared theta. Ooh, wow, this question is getting hot. But anyways, let's just do what we can. Here we can take out, let's take out 4 as a common factor between these two and see what happens. Or rather, let's change these to like the same trig ratio. So let's change it to like, let's change this one to something that has a cos, you know. So let's see here, cos squared theta. Let's see here, cos squared theta plus let me remove everything, minus 3 plus 4 cos squared theta plus what, 16, right? And then here I can put like cos squared theta, no, 1 minus cos squared theta, bro, come on now, 1 minus cos squared theta, like that. I'm just working with the right hand side. So this is like negative 3 plus 4 cos squared theta plus 16, if you multiply inside, minus 16 cos squared theta. Simplifying all this, you're gonna get, let's write it in alphabetical order of some kind. Not in alphabetical order, in like standard form. Whoa. Here 4 minus the 16 gives you I think like a 12. Yeah, negative 12. Negative 12 cos squared theta. And then here 16 minus 3, that's like gonna give you a positive 13. Uh-oh. Here. This is scary. Oh. Okay, this is just scary. Let me not say scary or like I'm a crazy person here. They said we should show that the radius of the circle can never exceed square root of 13 for any value of theta. Show calculations. Wow. Oh well, so anyways, the right hand side here is always going to give us r squared. Remember, in standard form, this is the center of the circle, the x value of the center, this is the y value of the center, and the other side is just r squared. So let's see, let's make sure we did everything correctly without messing up here. Change this to 1 minus that, multiply inside. This gave us negative 12, this gave us 13. Oh well, so here we know that this here is equal to like r squared, right? Of which the square root of both sides is just gonna be square root of negative 12 cos squared theta plus 13. This is equal to r. Now comes the question, how does this show that the radius can never go above square root of 13? Now, the idea is you just need to work with the cos part. This part here, right? We know that this number here, it is always going to come out as a positive number. Like, regardless of anything, right? This number here is always going to be a positive number. Of which, apart from it being a positive number, we know that the highest that this can go to is obviously going to be a positive 1. You see, let's say here highest is going to be equal to positive 1. Whatever value of theta that you're going to put here, the highest that this will ever be is a positive 1. The reason for me saying that is that, let me explain it here. Firstly, what I'm trying to say is, here if you leave it like this, your answer is 100% correct. The reason is the graph cos y looks like this. Remember, the graph cos y goes between positive 1 and negative 1. So the highest value of cos y is a positive 1 anyways. So the highest of this number is a positive 1. The lowest of this graph, the highest of this graph is a positive 1. The lowest of this graph is also a positive 1. So what we know is whatever value for theta that you throw in there, it's always going to be between 1 and negative 1. And if you square it, it's always just going to come out as a positive number, of which the highest that can come out from here is a 1. So if you square a 1, you still come out with a positive 1. So the highest here can be a 1, right? So if you say negative negative 12 times 1, you're going to get negative 12. And then negative 12 plus a 13 is going to give you, what is negative 12 plus 13? Negative 12 plus 13 is going to give you square root of 1, of which square root of 1 is just a 1. Well, that's kind of crazy. So let's just carry on. The highest here, we said it can be a positive 1. Yeah, this kind of question is kind of tricky, but it is what it is. Here, so the highest value of r is going to be negative 12 with the 1 here, plus the 13 here. And then this is just going to give you square root of 1, which is just going to give you a 1. You see, this is telling me that the highest value of r is just always going to be a positive 1, coincidentally. Whew, yeah, this question, yeah, if you have any objections, please let me know. Just hit me up, and then we will just be able to like work on it. But for now, this is what I've got, and if you spot any funny small errors, just hit me up as well. But for now, I think this is okay. Number 12, it says in the diagram below, which is this diagram over here, it says E is this point. It says E is a point on the y-axis and D is a point on the x-axis. Okay, there's E and D over there. And then it says C is a point on the line EB. Yeah, C is a point on the line EB, and B lies on the x-axis. Then it says here ECD is equal to 79.29. Yes, meaning the other side is going to be 100 and something. Yes. Then it says the gradient of CD or DC is like 0.35. For how many marks? I don't know. They said we should determine the coordinates of B. Yeah, you see, not seeing the marker location is a big problem, but we'll just try and do what we can, you know. So let's see. They gave us, what did they give us up front? They gave us this as 79.29, meaning this is 100.71. Well, they gave us the gradient of this line. Let me actually just remove these because I'm like, I really don't think we should highlight those for now. They gave us this gradient. What does this gradient help us with? X coordinate of B. Yeah, here we kind of do have to think outside the box. Otherwise, we're gonna spend a long time here on this question because I'm thinking to myself, can we? Why am I yawning like this? Yeah, you see here, not seeing the marker location is like a big issue because I don't even know how much I should think or how hard I should think. But anyways, we do have a Cartesian plane here, so this is a 90-degree angle, and we don't know what do we know? We don't know anything. We don't know the length of. Let's just, you see, when I'm stuck, I'll always go back to the description again, like legit. It says here C is a point on ED and B lies on the x-axis. So let's see here. ED is equal to 79.29, and then the gradient of DC is 0.35. Yo, I'm thinking to myself, what happens if I get this angle here? I don't know. We can easily get it because we have the gradient there. So we'll have this angle, we'll have that angle. Let's see what happens if I also have this angle. Oh, then I can use it to get the gradient of the line EB, of which if you have the gradient of the line EB and the y-intercept, you can get the equation of the line EB. Okay, yeah. So let's get angles here and there so that we can get this angle here, because this angle here can give us the gradient of EB, of which if you have the gradient of EB, you can eventually get the equation of this straight line and then use that to get B. So let's do that. Let's get the angle D here. We can use that using the gradient formula for tan. You see, like if you say tan the tan what? You want the angle, right? So tan, the angle we don't know. So let's say here CDB, this is equal to 0.35. So shift tan. So here you have to be careful though, because you might get an obtuse or an acute angle here. You just have to choose which one you need. Shift tan 0.35. You see, I don't got my calculator, but you know, Android. This way Android is useful, because unless it's just me, but let me not embarrass myself because I cannot find the scientific calculator on the iPhone. But anyway, let's see here. Shift cos with 0.35. As you can see, it is raining. So it says 19.3 over here. Let's see, CDB. This is 19.3. Yeah, it's definitely this angle here, 19.3. So it means that CBD, so it's like CBD is like equal to 180 minus 100 and let's see, 100.71 minus 19.3. Let's see what this gives us in the calculator. We're gonna get the 180. Let's say 180 minus 100.71 minus 19.3. That's like 59.99. You see, 59.99, like that. So this is like 59.99. So that angle we can use it to get the gradient of EB. So here we can say 10, 59.99, 59.99. Let's see here the gradient. You just have to be careful now. Here you have to make sure whatever you get, take it as a negative. So let us do that. 10 with 59.99. Let's see what you're gonna get here. Let's clear everything. 10, 59.99. That's like 1.73, right, as the gradient. So here you're gonna get 1.73, which is okay because the other gradient also is like to 2 decimal places and stuff. So, but then the issue here is, if you're gonna use the 10 formula, right, you actually usually need to use your obtuse angle side if you want this negative gradient over here, because see, this cannot be a positive number. You see, this gradient here cannot be a positive because, I mean, like, you know, it's a negative gradient. So let's just do that quickly. Let's just use 10. Yo, what am I doing? Come on, bro, come on. 10, 180 degrees minus 59, 55.99. If you put this into the calculator now, look what you're gonna get. Let's put here 180. You see, you're getting the negative version. So even if you didn't do what we're doing now, it doesn't matter. You can always take your answer here as a negative because, I mean, like, look, this is a negative gradient anyways, you see. So that's the gradient here. So here we can then say, if you want the equation of this straight line here so that you can get the x-intercept, you know that the equation of the straight line, you can get it from this. Y minus y1 is equal to m and then x minus x1. So from here, you have y minus, the y value here that you have is like a, why am I doing all this when we actually have the y-intercept? So here we can then just conclude and say, therefore, y is equal to yada 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 yada. Let's see here, y is equal to negative 1.73x, and then the y-intercept is like a positive 12 over there, plus 12. There we go. Whew, okay, so now we just need the x-intercept of b, right? The x-intercept of b, we just need to make y as 0. So y here is going to be a 0, negative 1.73x plus 12. Take that to the other side. And then here divide both sides by 1.73. 1.73. Let's see, 12 divided by 1.73. Come on, calculator, you've been so useful. Keep on being useful. 12 divided by negative 1.73. Is that what I should be doing? Or is it the other way around? Yeah. No, it's a positive, bro. Come on. It's a positive. So it's like 6.94. 6.94. Whew. Therefore, the coordinate of B, 6.94, coordinate 0. That is the way we like it. Ooh. So, let's see here. For 13 marks, what you're gonna do. You have here, it says in the diagram below, the line, this, that. No, it says in the diagram below, the line from K to J. Where is K to J? Out. The line from K to J is a point here, a point there. The line from K to J is a chord of the circle with center A. A chord with center A. And then it says here CD is a tangent to the circle at D. Yes. Looks like there's a lot of information that they're going to tell us here. Then they said C lies on the y-axis. So all this, don't take it for granted. For 8 marks to end things off, they say calculate the coordinates, determine the coordinates of A, and then show all calculations. Oh well, so getting the coordinates of A, it's not going to be straightforward because it is out of 8. But take note of key things that they've given you. Firstly, this is a tangent. So don't be afraid to make these kinds of constructions. You see, this is a 90-degree angle. Okay. Secondly, this distance here is the same as that one over there. The same as that one over there. Now let me just write this one a bit better. See this dotted line here. So these 3 can help us, maybe one more or the other. We'll see. What else? Well, this is what? Yeah, this one's gonna be tricky, I don't wanna lie. Because you can't really say there's a specific way to start, You could think to yourself, why don't we use the distance formula and all that? But yeah, with these kinds of questions, the distance formula usually does not help much, because if you think to yourself, the distance from here to there is the same as the distance from there to there, which is also the same as the distance from there to there. But then if you do stuff like that, you're gonna end up with I don't know, it's just gonna be a bit messy. And then the other question you want to be asking yourself is, why have they given us this y-intercept if we are supposed to just use the distance formula and all that? So those are the kinds of things that you can be thinking to yourself. But then another thing that does stand out is that you see this y value here is the same as this y value. So it means that there's a straight line over here. You see, it's a line that is parallel to the x-axis. So let's just take note of this line over here. It may help us, it may not. We'll see. This is parallel to that. And then what that then means is that if you look at the x values now, you see this x value here is a 2, this x value here is a 4. So I'm just trying to justify what I'm about to say right now, because what I'm about to say right now may just freak people out a little bit, because I was about to say the a value is in the middle here, but I'm trying to justify saying that because I really want to say that, but I still don't know how to justify why I would say that. So let me just think a bit and then carry on with the thingy, because we're almost done anyways. To be honest, this whole tangent here, I'm not liking it at all, because it's just making things weird. So I'm just going to disregard the tangent. So this is a circle. And remember, circles are infinitely symmetrical, in the sense that if the y value here is a 4, and the y value here is also a 4, and this is the center, what we know is that obviously this is a straight line. It just means that if you think of it nicely, right, this line here is equal to that line, duh, because it's like the radius of your circle. And we said here the x value here is a 2 and the x value here is a 4. So obviously in the middle of the 2 and the 4, that's where you're going to get the x value of the center of your circle, because this is in the center, right? Obviously, if you think of it, this is the middle of dk, you see. So this is a line from the center. If it goes towards the middle of dk, we know that this will just be a 90-degree angle, and we know that this will be equal to that, you see. So let's just try and have them know that we know all this before we write out that the x value of a is like 3. So what we know is, let's say here construct let's call it AE. You see, construct AE perpendicular to DK. So if AE is going to be perpendicular to DK, or let's construct DK first so that we can show that DK is like a straight line. So let's say here construct DK. Construct DK. Okay, if you construct DK and also construct EA perpendicular to DK, you're going to end up with DE, or ED rather, or DE, call it what you want. You're going to end up with DE being equal to like EK, The reason there is your construction. That's a constructions are such a heck. Construction. Okay, you having to have done that, hi boy, you know that technically speaking, the x value of a is now going to be a 3, because if this is a 2 and this is a 4, right in the middle here, you know it's a 3. So here you can then say, therefore a, you know that the x value is a 3, the y value you don't know yet. So now you can easily work out your, what did they want us to work out in the first place? I'm forgetting the coordinates of a. So here now you know that a is just 3 coordinate y. So we know that the distance for this line here is the same as the distance for that line over there. So now we can just use the distance formula. I know I was like talking against it in the beginning, but now I'm just like, looks like that's the only way here. So using our distance formula, I'm actually crop this thing so that I can also like write on black for a change. I miss writing on black. Writing on black is so convenient, yo. So let's see here. We already know that the distance formula here, AK is equal to AJ because of the red eye. AJ, just red eye. Like that, right? And then what the else, bro? What the else? That's like, so let's say here AK, if you use the distance formula, right, you're gonna have the square root of like let's use the x values first. 3 minus 4 there, so it's gonna be like 3 minus 4, the whole thing squared. And then here y minus 4, let's say here y minus 4, the whole thing squared. Let's see here, let's go back, let's do that. So this is equal to square root of AJ. Where is AJ? So it's like 3 minus 5 for that one, 3 minus 5 squared, and then this one is like y minus 3 plus y minus 3. There we go. So obviously both sides, if you square it, the square roots go away, so you're gonna be left with like 3. If you square both sides here, let's see, square this side, square this side, this is just going to be like a minus 1, so it's like 1 squared, it's just 1. Then here y squared is just y times y is y squared, and then negative 4 times the y, you're going to end up with like negative 8y, and then negative 4 times negative 4. It's going to give you a positive 16 if you FOIL out this bracket. On the right side, 3 minus 5, that's like a negative 2. Negative 2 squared is like a 4. Here, y times y is going to give you a y squared. And then y times the negative 3 is going to give you a negative 3. And then negative 3 times the y, you would end up with like negative 6y there. And then negative 3 times negative 3, that's going to give you a positive 9 like that. Whew, let's move everything to like one side. Let's move everything to the left. So the good news is because both sides have like y squared, this is going to cancel that if they go to one side. And then here 1 plus 16 is like a 17, right? And then 4 plus 9. What is 4 plus 9? 4 plus 9 is like a 13. And then here you have like negative 6 plus 8, that's like a positive 2y. And then 17 minus 13, that's like a 4. And then divide both sides by 2, that's like a 2. Let's see. Yeah, everything looks fine here. The y value is a 2. And it kind of makes sense because this is a 3. So the y value there definitely kind of does look like it's a 2. So this question, the whole being given tangent thing, that's like the most useless piece of information I've ever seen, because there's nothing, this tangent has not helped us in any way, but it is what it is, you know. It is what it is. With this kind of a question, I think just spotting this as a 4 and that as a 4 really did help us, because it shows that this line here is parallel with like the y-axis. So because of properties of your circle, it has helped us to see that, okay, this is just in the middle of the 4 and the 2, which is just a 3. And then eventually we just use the distance formula. Wow, man. Anyways, I can safely say that this question paper was not your everyday question paper. It was kind of tough. Not kind of tough, it was genuinely tough, to be honest. But there were some questions here where obviously things like the different courses, yeah, they obviously do help. Not because it's like some of the questions are like exact, but just, you know, some of the theory and everything like that really would be like, for example, a lot of the stats questions here definitely from the course platform. Some Euclidean geometry over here. Overall, I think it was a maybe like 50-50 one or the other, because most of these things, you see, theory is needed for like things like that, the mean and the everything and all that. Yeah, there were some questions like this. This one was kind of weird, but it is what it was. Properties of trigonometry. I'm just move this back. No. Come, what you doing? No. What did I just remove here? Oh, I removed the 2 over there. Anyways, that's that from my side. Thank you so much. I will catch you in the next tutorial, but then this one was a special kinda tutorial, so it is what it is. Let me just end things off here. If you need any help, you can just hit me up on IG, and if you need help, deep help, you can always check out the course platform. You see courses dot bright young brains bright young brains bright young brainser .co.za. There we go. Okay, that's all that. I'm gonna go now. It's been a long day.